Good morning and hello. So we are from group 3 and we will present about linear algebra and its applications. So this is our group member, which is me, Welna Azlam, Nurul Hidayah Hikmah, Saadila binti Sahili, and Nurul Amira Balkis. For our list of content, we will present about the introduction of linear algebra, the applications, conclusion, reference appendices, and the meeting minutes. For the introduction, Nurul Amira will present it, and for the applications, we include two applications, which is application in data science, which will be presented by Saadila binti Sahili, and application in engineering will be presented by Nurul Hidayah Hikmah, and I, Welna, will present the conclusion of the linear algebra and its applications.
I am Nurul Amira Balkis. I will explain about the introductions as we choose linear algebra and its application. So I will explain the definition of linear algebra. As we know, linear algebra is fundamental branch of mathematics. Linear algebra is focusing on linear equations and their representations using vectors and matrices. This field is vital for solving complex problems in various domains, including engineering, data science, statistics, physics, and also economics. By understanding and applying linear algebra, we can analyze data, we can model systems, and also develop efficient algorithms to address real-world challenges. And linear algebra also explores concepts like vector, linear transformations, and systems of linear equations.
Why is linear algebra is actually useful? There are very many applications of linear algebra. In data science, there are several ones of high importance, including in machine learning. Algorithms like linear regression, support vector machine, and neural networks depend on the algebraic operations to identify patterns and relationships in data. These algorithms make use of matrix multiplication and other linear algebra techniques to ensure that the predictions are as accurate as possible. For example, linear regression uses matrices to solve equations to predict outcomes based on input data. Another important use of linear algebra in data science is dimensionality reduction. The principal component analysis and singular value decomposition techniques help reduce the number of variables in dataset while keeping the data integrity. This speeds up the machine learning processes, making the complex data easier to analyze and reduces computational costs. Linear algebra is foundational to statistical methods such as logistic regression and cluster analysis, which are used to analyze patterns in data and make decisions. Last but not least, linear algebra is significant in the fields of computer graphics, where the matrix operations are used to achieve transformation, rotations, and scaling of images. This is crucial for image processing and graphics rendering. To conclude, linear algebra is relevant and crucial in modern data science as it helps and facilitates challenges arise in many aspects of life.
Assalamualaikum and hi, I'm Nurul Hidayah Hikmah and I will present engineering in linear algebra. There are few applications of linear algebra used in engineering, including structural analysis, signal processing, circuit analysis, robotic, and vibration analysis. In structural engineering, linear algebra used to analyze designs and structures such as bridges or buildings. For instance, finite element analysis (FEA) use linear algebra to solve stress, strain, and material deformation by solution of system of linear equation. Outside of that, Kirchhoff's law results in system of linear equations that represent voltages and currents. Fourier transform decompose signals into components for filtering, compression, and analysis, which enabled by matrix operations. Moreover, linear algebra also applies in robotics, where the matrix operations model the robotic arms movement. It also applies in vibration analysis. For example, eigenvalues and eigenvectors that identify natural frequencies of mechanical systems.
In conclusion, linear algebra has many applications in the real world. As we know, linear algebra is a branch of mathematics focusing on linear equations and their representations in vector spaces through matrices. As mentioned before, it is a vital and adaptable area of mathematics with widespread implications across numerous domains, from data science and engineering to physics and economics. In data science, linear algebra helps data scientists understand and manipulate large data sets using many concepts such as vectors, matrices, and linear transformations. We also can see that there are many important uses of linear algebra in data science, such as machine learning, dimensionality reduction, statistical analysis, and image processing. Other than that, for engineering, it can help with structural engineering, which serves analysis and design of such structures. Linear algebra also can be applied to robotics, for example, using a matrix operations model to move into robotics arms. Lastly, vibration analysis can help identify the natural frequencies of mechanical systems. As technological advancements progress, the need for knowledge in linear will only grow, highlighting the importance for individuals to grasp its principle to remain competitive in an increasingly data-centric and high-tech environment. For those aiming for careers in areas like data science, engineering, or many fields that involve systems modeling or computational analysis, having a solid grasp of linear algebra is strongly advised. By becoming skilled in these methods, individuals will be prepared to tackle complex issues, enhance processes, and aid in groundbreaking development within their fields. In this section of presentation, this is the reference we used for this assignment. Each reference was selected carefully to support the key arguments and concepts presented in the paper. Now, I'll be presenting the meeting minutes from our recent meeting. The meeting took place on 24 November 2024, starting at 2:30 until 3 in the evening. We gathered virtually on Google Meet, which allow all members to participate efficiently from different locations. All of the group members, which is me, Saadila, Nurul Amira Balkis, and Nurul Hidayah Hikmah, all present at the meeting. Now, let's move on to the key points we discussed. The agenda for this meeting included three main items. Firstly, the division of duties, which is me, as Wilna, will do the cover page, contents page, conclusion or recommendations, and summarizing the main points. Nurul Amira Balkis will do the introduction and definition of linear algebra. Nurul Hidayah is about the detailed information of linear algebra and its application in engineering. And Saadila's part is about the application of linear algebra in data science. The second agenda is the selection of main text, and we choose the second, which is linear algebra and its application. The third agenda we talk about what will be covered for the next meeting. This included deciding the focus for our next steps. The meeting adjourned at 8:30 p.m. the following day.
Next is our second meeting minutes on 25 November 2024 at 2:30 until 3 p.m. We use Google Meet as our platform. All of our members attend the meeting, and our agenda is we discuss on each part where the definition and introduction of linear algebra was completed by Nurul Amira Balkis, but needs some revision and additional information to enhance its content. The first application, data science in linear algebra, assigned to Saadila binti Sahili, is not completed yet. And the second application, engineering in linear algebra, contributed by Nurul Hidayah Hikmah, has been outlined in points and will be elaborated further. Then the conclusion will be written by Welna Azlan after all of the completion of all other parts. A follow-up meeting will be scheduled for 26 November to review the progress and discuss on video presentation. Saadila binti Sahali will organize the meeting and send out an agenda.
Our third meeting is at 26th of November 2024. We allocated the time from 8:30 to 8:50 in the evening. We use Google Meet as a platform of discussion. The attendees are me, Saadila, Welna, Nurul Amirah Balkis, and Nurul Hidayah Hikmah. We discuss on two agendas, which is first, review the progress of each member's tasks. All content of main text has been completed except Hidayah's task that need to be more elaborated, and Welna's part, which is to conclude all of the discussion met. Next, we discuss about the slide and video presentation making. We use Canva for the slide and video presentation purpose. All group members need to participate in making the slide, and each group members need to record video representing on their tasks respectively. All works need to be done by 9 p.m. on 27 November of 2024 before the last meeting will be conducted. Meeting agenda is at 8:50 p.m. and this minute is prepared by me, Saadila binti Sahili.
Next is our fourth meeting. Our fourth meeting is the last meeting and we held on 27 November 2024. We allocated the time from 9 p.m. and we use Google Meet for our platform location. And all group members are attend, which is Saadila, Welna, Nurul Hidayah Hikmah, and me, Nurul Amira Balkis. And we discuss one agenda, and of course we discuss about progress of each other slide and video. And we discuss all that to make improvements or correction. And each group members have done making the slide and record video representing on their task respectively, except the meeting minute slides and video. And our work need to be done by 8 p.m. on 28 November 2024 before the last recheck and submit on ITEL. Meeting adjourned at 9:10 p.m. and meeting minutes prepared by me, Nurul Amira Balkis. And that's all from us. Thank you.
So that's all from us. Thank you.